Welcome back. This is Mr. Hassan's Maths channel, and now I'm answering question number 17 from the specimen paper B of the 0580 IGCSE Cambridge extended paper 2. This is the non-calculator paper, and here we have a question dealing with this sector of a circle. So they told us in this question that the diagram shows a sector of a circle with radius 6 centimeters. The area of the sector is 15 pi centimeters squared. We got to work out the perimeter of the sector. So what we need to know is some of the angles, so some of the formulae dealing with the area and the perimeter of sectors. Now if we go to the formula sheet and see, do they give us anything like this? We will be able to see something here. They didn't tell us anything about sectors. They've told us about circles, and they've told us about the area of the area of a circle and the circumference of a circle, which will come in useful for us, but we should know these anyway, right? But these two will help us in this particular question. Okay, so if we go back to our question now, where are we? It's over here, a bit further on. Okay, so now what we should know is that the length of the arc of a sector is given by the angle, which is theta, which we're going to call this angle here theta, okay, over 360 times 2 pi r. That is the length of the arc. That is the length from here all the way around to there. That's the length of the arc. Okay, that's the length of the arc. Okay, just the curved part. And the area of a sector is given by the same thing, the angle over 360 times the formula for the area, which is pi r squared. Now, if you forget those two little parts of it, you can go back to the formula sheet to find out, but you shouldn't really forget that. You should understand that. So the area of this sector is 15 pi centimeters squared. And we want to work out the perimeter. So to work out the perimeter, now what we have to understand, the perimeter is the length of the outline of the shape. So the perimeter would be 6 plus 6, which is 2 times the radius, plus the length of the arc. Okay, so we know this is 6 centimeters, so we got these, that's fine. I need to know what the length of the arc is. To find the length of the arc, I need to know what this angle is. Theta over 360 times 2 pi r. I have r. I need to know what this angle is. How do I find this angle? Well, I can use the fact they gave us the area, right? So our objective now is to find the angle theta. To find the angle theta, we can use the fact that theta over 360 times 2 pi r, times pi r squared, which is for the area, is equal to 15 pi. I can cancel out the pi straight away. So I can say theta, and we know that r is 6. So I can say theta over 360 times, that's going to be 6 squared, is equal to 15. So I can say theta is going to be 15 times 360 over 6 squared, which is 36. So we can see this cancel out nicely. This becomes a 10 here. So the angle is 150 degrees. So we know this angle now is 150 degrees. So now we want to find the perimeter of the sector. So the perimeter is going to be the length of the arc, which is 150 over 360, theta over 360 times 2 times pi times the radius, which is 6. That's using this formula over here, plus 2 times the radius, 2 times 6. Okay, so that gives us, they cancel out. Okay, that can cancel out with that, give me 6. That can cancel out with that, give me 3. 150 over 3. So 15 over 3 is 5. So we got 5 pi plus 12. So you end up with 5 pi, or we can say, if we want to write it in this form, we want to have the pi term first, it's going to be, it's going to be 12 plus 5 pi centimeters. So all this cancelling out, can be done easily if you just look at things that can cancel out from the numerator and denominator and leave you with an easy sum to make at the end. So 12 plus 5 pi is our answer. Our answer in the form that they want us to leave it in the end. So in this question here, we want to find the perimeter. We had the radius. The only thing we didn't have was the angle. Okay, and that's what we need to find the length of the arc. So we have used the fact that gave us the area to find the angle, and then that angle we used in this formula and we got our answer. So other questions from this particular paper here can be found in the playlist, which will be found in the top right of the screen at the end of the video. Other questions from the topic of areas of circles and sectors and so on can be found in the playlist over here. The general kind of playlist for all questions dealing with areas and volumes and so on can be found in this playlist. And you can subscribe to my channel by clicking on the link at the top. Thank you for watching and see you soon.